Most users solve this problem using a linear search. It works, but can we do better? What if the array contains 1 million elements? Today, I will show you how to solve LeetCode 35 using binary search in just O O log n time. So, let's first understand what the question is saying. We are given short array, a sorted array, or target value. Our task is to return the index if the target exists. Otherwise, we return the position where it should be inserted. Let's see the example. Here, nums array and a target 5. The 5 already exists, so and the index of the 5 is 2, so the answer is 2. In the second example, you can see our target is 2, but it does not contain 2. So, where we should insert it? Between 1 and 3. So, the insertion position is 1. So, the answer is 1. To solve this question, we can solve it with two approaches. One, the brute force approach to solve this question is that the first idea that comes into our mind is the linear search. Traverse the array with the target found, return the index. Target smaller than the current element, return the current index. But this works, but the time complexity is O of n, and we can do it better. Because the array is sorted, so why binary search? Where you hear sorted array, thinks binary search. Binary search allow us to eliminate. So let's see our approach to code and let understand the every line of the code one by one. So before writing the code, let's think about the problem. First thing I noticed that the array is sorted. Whenever I see the array sorted array, binary search should immediate come to our mind. Why? Because instead of taking every element one by one, binary search allows us to eliminate half of the array in every step. If you use linear search, I would start from index 0 and keep taking the element until I found 5. But with the binary search, I directly jump to the middle of the element. The middle element here you can see the 3 uh, in this example. Now compare the target with the middle element. Target is 5, middle element is 3. Since 5 is greater than 3, I know one important thing. Everything on the left side of 3 is also smaller than 5 because array is sorted. This means I can completely ignore left half. Now I can search the in the right half and again I calculate the middle. Now middle is our 5. So target found and we return the index. So now you can take another case. Here you can see nums 1, 2, 3, 5, 6 and target is 2. Target doesn't exist. What should we do? Let's perform binary search in this also. The middle element is here again 3. Since 2 is smaller than 3, move to the left half and now the middle become 1. Since 2 is greater than 1 and I move to the right. Eventually the search space become empty. At that moment, notice something interesting. The left pointer is pointing exactly where 2 should be inserted. Index 1. Index 1. So that's why after the loop end, we simply return the left. Because if the target exists, we will return its index inside the loop. And if the target doesn't exist, left automatically point to the correct inserted position. So this approach is binary search because the array is sorted. Compare the target with the middle element. Search the left to the right half accordingly. The target is found. Return its index. The target does not found. Return left because it represents the correct insertion position. That is the key idea behind the entire problem. So let's see this detailed approach in the code. Here, as you can see, we passed all the test cases. Uh, that's how we solve the LeetCode problem, search insert position. So if you like this explanation, please like and share the video and subscribe to the channel and stay tuned for the next video.